Let A and B be two events in a sample space. Okay, so suppose that P of A equals 0.4 and P of A or B equals 0.7 and P of B equals K. For what values of K are A and B mutually exclusive? When you talk about mutually exclusive events, you're talking about events whereby the intersection is 0, P of A and B is 0, right? So they want to know the value of K that will make event A and B to be mutually exclusive. So what we're going to do now, we're going to use the general formula or the general rule of probability. I hope that makes sense. So it will be P of A or B equal to P of A plus P of B minus P of A and B. Then we can actually substitute the values that we are given. We do have P of A or B, which is 0.7 and equal to 0.4 plus K minus 0. So even if we don't write it, so 0.7 minus 0.4 is 0.3. That's the value of K. So this is the answer. This is the value of K that makes P of A and B to be mutually exclusive. So let's try to prove it and use the general formula again to determine now the value of P of A and B. If where there's K, we substitute 0.3 to check if P of A and B is going to be 0 or not. So if it's 0, it means that our answer is correct. Okay, so we do have 0.7 as P of A or B. We have 0.4 plus 0.3 minus P of A and B. So we must actually solve for P of A and B. Therefore, 0.7 equals 0.7 minus P of A and B. Therefore, when we transpose the 7 to the left, it will be 0. Therefore, our answer is correct. The value of K is accurate. I hope that makes sense. Then let's try to solve 11.2. Now, for what value of K are A and B independent? So when we talk about independent events, it's when we actually multiply P of A and B to get P of A and B. So the intersection must be equal to the product of P of A and P of B. Okay, we do have P of A as 0.4 times P of B, which is K. Therefore, P of A and B equals 0.4 K. Therefore, we can use the general rule and substitute this value where there's P of A and B, so that we can be able to determine the value of K where the events, event A and B are independent. Therefore, P of A or B equal to P of A plus P of B minus P of A and B. For the value of P of A or B, we have 0.7 equal to P of A, which is 0.4, plus P of B. We do have P of B is K minus 0.4K. Therefore, we transpose the 7 to the right, to the left, 0.7 minus 0.4 is 0.3 equals K minus 0.4 is going to give us 0.6. So it's going to be 0.6K. Then we divide both sides by 0.6 and solve for K. So the value that we're going to actually get here, it is the value of K that makes A and B to be independent. I hope it makes sense. You can prove it if you like. So that's very, very important. It's all about knowing and understanding the events, that when they talk about mutually exclusive events, what is it that they're actually talking about. When they talk about independent events, what is that they're talking about. Or you can actually use that value of K and check if A and B are mutually not mutually exclusive, but are independent events. Yes, so that's very, very important. And actually we do have a lesson. Make sure that you do watch it under probability.